Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%.
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
With Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. My guest today is Kerri Donaldson Hanna. She's a planetary geologist and an assistant professor in the Department of Physics at University of Central Florida, UCF. So we're going to talk about, what are called airless bodies, the moon, Mercury, Mars, asteroids, etc. And, do these things change over time? Do they evolve? What happens with them? So welcome, Carrie. Thanks for coming.
Yeah, thanks for inviting me to join your podcast, Richard.
Yeah. Well, tell me a bit about your background first, and then, how you got to be interested in these airless bodies, I guess we could say.
Yeah, airless bodies, I think, makes things sound a little bit more exotic. But essentially, what I really am interested in studying is any planetary body in our solar system that doesn't have an atmosphere. And so that kind of rules out things like Mars and Venus and Earth. And so I mostly focus on the moon, Mercury, and asteroids. And that area of research really kind of started from an undergraduate research project that I did when I was finishing up my bachelor's degree and doing a bit of spectroscopy and telescopic observations of Mercury. And that just kind of excited me and started getting me to think about how can I pursue that further. And so I eventually went into grad school to study the moon and doing spectroscopy and thinking about how we can use that to understand how bodies form in the solar system.
Okay. So, what is what body is the most well understood? Is it like Earth's moon, certain asteroids, and why?
Yeah, that's a good question. So, it depends on what level of detail you're talking about. If we think about probably the most studied body and probably what we know best, the moon's probably up there. Because we've had several orbital missions, the spacecraft that have gone and orbited and taken a lot of high-resolution data. And then we've also had astronauts there. And so those astronauts have gone to the surface, collected rocks, brought those rocks back so that we can study those in the lab. And that's really allowed us to better understand all of our orbital data and data that we get from rovers, because we can study those rocks here in the lab on Earth. And so that, I would say the moon is probably the most well-studied. And then Mars is a close runner-up because the amount of data that we have from Mars is unprecedented, especially when thinking about the spatial scales or how small of things we can detect at Mars' surface.
Well, again, so what is has there been change in these bodies over time, and if so, when? Like, what has been learned?
Yeah, so for the moon, when we look at its surface, we kind of see two different terrain types. We see really bright regions that are kind of a lighter gray, and we can see circular depressions in those terrains, and those are all from impact craters. And then we also see large, kind of black or very dark flat seas, or what we call mare. And there's also impact craters into those as well. And so when we think about the history of the moon, we know that most of the volcanism that fills those dark seas, and also the impact craters. Most of that really happened about 3 to 4 billion years ago, but impact events are still happening today on the moon. We see impacts happening almost on a daily basis there. They're just at a small scale, but we have telescopes trained to look at that. And if we think about volcanism on the moon, there are some features that likely formed about 100 million years ago, which in geology terms is pretty young.
So what is some of the most recent things that have happened on the moon, for instance?
Yeah, so geologically speaking, the most recent things has probably been some of the young volcanism and these what we call irregular mare deposits, which are these really weird looking features that have unusual textures at the surface where they have really smooth areas, but then they also have really blocky and rocky areas that are really distinct from their surrounding terrain. And then we do see evidence of rock slides similar to landslides here on Earth. And those likely are still occurring because we do see some evidence for continual tectonic activity creating those landslides and then the impacts. And so those are kind of the three things that are more recent geologic activities on the surface of the moon.
Is there, is there much tectonic activity on the moon? And then also Mars? I really haven't heard much about that.
Yeah, so most of the tectonic activity on both of those planets, so both on the moon as well as Mars, is really just coming from the interior of those bodies cooling off. And as the interiors cool off, they shrink, and then that causes the outer crust or the outer layer of those planetary bodies to also shrink or crack. And that's where that tectonic activity comes from. And we see evidence for that on Mercury as well, is that as these bodies cool, they shrink, and the crust breaks and fractures from that shrinking process.
Okay. Compared to Earth, I would guess the moon and Mars and other planets, are they very quiescent compared to Earth, or do they have a lot of volcanic and other events going on?
Yeah, in comparison to Earth, all the bodies that we've been talking about are very quiet. We consider all of these, the moon, Mercury, Mars, geologically dead, meaning there's not a lot of activity that's going on at them. So even when I say there's like active tectonic activity that could be happening on them, creating these landslides, it's very minor in comparison to what we think about all of the geologic activity that we see on Earth, right? On Earth, we see active volcanism. We see earthquakes happening due to tectonic activity. And so on Earth, we live on a very geologically interesting and active body, which we just don't see anywhere else in the solar system.
What about like Jupiter, for instance? I've heard there's huge storms on Jupiter, and the eye is a result of a never-ending storm. Are there other planets besides Earth or other bodies that are very geologically active?
So we do see there's possible evidence that Venus is geologically active. There's been some reanalyzing old radar data sets of Venus, which suggest there could be volcanism going on in recent times. And we certainly see when we look at Venus's surface through its fairly thick atmosphere, we see very few impact craters at the surface, which is what we kind of use to estimate an age of a planetary surface, because you could almost think of the crust of any planetary body as a witness plate. And over time, you just have a lot of impacts on the surface. And so the longer you've had that witness plate available to it, you'll have more and more impact craters. So really old surfaces have a lot of impact craters. When we look at Venus, we see very few impact craters. And so that would suggest that there is volcanism going on, and that the surface has been resurfaced maybe multiple times even. But because it's hard to view the surface of Venus through its thick clouds, we can't actively watch volcanism going on. So we haven't been able to actively or see active volcanism. But when we looked at the outer solar system, we do see evidence for active volcanism and have observed active volcanism. So we can think of some of the moons out in the outer solar system, like Io. Io is probably the most volcanically active planetary body in the entire solar system. You see sulfur-rich volcanism happening all the time. And then some of the icy moons like Europa and Enceladus also have evidence for geyser-like features. So you have volcanism, but instead of spewing liquid rock, it's spewing ice. So icy volcanism. And there's been evidence for that kind of activity on those planetary bodies.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Well, what about, again, like Mercury or, it's so close to the sun. I would think the sun-facing, I don't know if it's locked, but the sun-facing side versus the non-sun-facing side, I would think there'd be a huge temperature difference. Wouldn't that make a lot of activity on the planet? Wouldn't that cause stresses and cause things to crack and move and, readjust?
So certainly the temperatures at Mercury's surface, especially the side that's facing the sun, it gets extremely hot. We're talking, about 300 to 400 degrees hotter than what we experience here on Earth. But when we're talking about volcanism and tectonic activity, that's really driven by heat in the interior of the planet, not on the surface of the planet. And the interior of the smallest planets really cooled off pretty quickly in our solar system history. And they have essentially cooled off and died, ending all the geologic and tectonic activity that we see on Earth. Now you could say, oh no, but you just said that these other smaller moons of the outer solar system are geologically active. And those have a lot of geologic activity because they're orbiting such massive giant planets that tidal forces are constantly tugging and pulling on them, generating heat in the interior. And so Io, as an example, is the volcanic activity is being driven by the gravitational pull of Jupiter on that surface, and it contracting and expanding and creating heat on the interior.
What about, all right, so, I know all these distances are very different. I had thought that the sun's mass was like 99% of the entire solar system's mass, but maybe Mercury is not nearly close enough to it as a moon would be to Jupiter to be affected by tidal forces from the sun?
That's correct. Yeah, exactly. So like if you did, as an example and a comparison, so on Earth, we actually have tides due to our moon, but also the sun. But because we are so far away from the sun, even though it is supermassive, the tidal effects on Earth from the sun are very small in comparison to that of the moon, even though the moon is much smaller. It's a proximity issue.
Okay, so yes, the moons around Jupiter are radically more close to Jupiter than Mercury is to the sun.
Correct. The moons around Jupiter are very close.
Okay, I see. I understand. So understanding these airless bodies and what happens, like it just seems like not much is going on. So what are the learnings that you've gotten from observing these?
Yeah, well, I think it's, it helps us really understand just how planets evolve over time in general. As you pointed out, our perspective on Earth is based on seeing active volcanism, active plate tectonics, active tectonic activity through earthquakes and such. And that tells us a lot about how Earth formed, but we can also see that in our solar system, Earth's pretty unique. And so then that means we have to understand how other planetary bodies form and evolve over time. And so studying these dead planets like the moon and Mercury and even some of the smaller moons in the outer solar system give us a better understanding of how our solar system in general works and how planet formation in general works.
I don't know, any really surprising things that you learned, in the past few years about any particular body that, like unsuspected activity that really surprised you, or, ideas of where, the fate of a certain, body or planet will be based on what's going on with it right now?
I mean, I think for the moon, what people are really excited about and energized about right now and really there's just a lot of activity going on, is the idea about how much water and what kind of water you might have on the moon's surface. And I mean, obviously, when we look at the moon, we know there's not lakes, we know there's not oceans. And for a long time, the thought was that there was no water at all on the interior of the moon or exterior of the moon. But now with recent spacecraft observations, we're starting to understand that, one, the poles of the moon can be some of the coldest places in the entire solar system. And it's because there's regions called permanently shadowed regions that get no sun throughout the entire year. Yeah. And so they are extremely cold. We've had a spacecraft even impact into one of these permanently shadowed regions, and looking at the ejecta from that impact let us use spectrometers and instruments on board to figure out what was in the ejecta, and we did see water. We've also now found water in volcanic glasses, which would suggest there's interior water to the moon. And we've also now started reanalyzing and looking at other remote sensing data or spacecraft data, and we can see that these spots are cold enough and that there's other indications that there could be frost or maybe water ice gluing the regolith grains or the grains and the soils together, or that there could be subsurface layers of water. And of course, that really drives interest to think about how much water there is, and is it enough that you could use it for astronauts at the moon, or could you use it for fuel on the moon? Is it a big enough resource that we could use it to not only have long-term people at the moon, but also maybe use it as a resource to get people further out into the solar system?
Okay. Is there anything that you, in your particular field, in your area, is there any understandings that you think we're close on? I know it's within the solar system, but can the Hubble telescope show anything? Can the James Webb now show new features that would help you discern what's going on with the various bodies in our solar system?
Yeah, so it's tricky to use Hubble and James Webb to look at things in our solar system, especially things that are pretty close to us, because they are such large telescopes. They can't actually look at things that are too close to, well, I should say Hubble can't look at things that are too close to Earth, that are decently sized, because the light bouncing off of them is too great and it would destroy the detectors that are attached to the mirrors of the telescope. And so sadly, we cannot use Hubble to look at Mercury or the moon or any of the inner solar system planets. And the same is true for James Webb, is even though it's a ways away from Earth, the moon and some of the inner solar system bodies are just too bright to study. And so we rely heavily on spacecraft data then to be able to study those planets, or sending rovers to the surface. And so there's been a big push to get a lot of rovers on the surface of the moon in the next 5 to 10 years.
But why couldn't we have a space telescope that rasters over the different bodies in our solar system? Maybe it sits at like a Lagrange point. Is there any good vantage point that's not too far away from us where we could do that, and it could observe again in succession all the different bodies?
Yeah, you could certainly have a smaller telescope in space that would do that. I guess the real trick would be finding the funding agency or a private company that would think that that's interesting enough to spend the money to do that, versus having telescopes on Earth.
I mean, is it possible, with the atmosphere and everything, if we have a telescope on Earth, could we observe most of the bodies in our solar system that we want to observe?
Yeah, so we do use a lot of telescopes on Earth to study all of our solar system. There are parts of the electromagnetic spectrum or wavelengths that are interesting to us that we can't observe. So it's difficult to observe like at the ultraviolet wavelengths. And it's difficult to observe in some portions of the near infrared, which those two parts of the electromagnetic spectrum are interesting because they can tell us about water on a planetary surface or different minerals that could be at the surface. And so having telescopes on Earth, we do have to fight with our own atmosphere. That makes it challenging, but it's not impossible. But even some of the largest telescopes on Earth, the moon, as an example, is too bright to look at. And Mercury is too close to the sun. And so it makes it challenging to observe with telescopes. So I'm definitely a proponent for your idea of having space telescopes that would allow us to study the solar system. But yeah, it's hard to find the money and the opportunities to build a spacecraft that would be able to do that.
Would it be just insanely expensive? I mean, like, if you compare like the money that went into the James Webb, would it be close to the same cost? Would it be a lot cheaper?
It would probably be cheaper, but you're always competing with other missions, right? So like when you're proposing a spacecraft to go do something, you're always having to build a scientific case for why you would want to do that. And you have to then, say why that's more important than studying something else. And so there's always this battle for research funding dollars. And, there's always so many exciting things to choose from to do next. And so I can't imagine trying to make that decision of what we should spend money on next. But yeah, it's just something that as scientists, we deal with all the time of like writing proposals and then trying to convince people that this is the thing we should do next.
Do you feel like the learnings that you're getting, about Mercury, about the moon, about Mars, are they going to be more widely applicable to other objects like, the asteroid belts, objects there, or like inbound asteroids, maybe like a Moaboa? Like what's the practical application you think of the learnings that you're gathering from studying these airless bodies?
Yeah, I think, certainly most of the asteroid belt or the asteroids that sit in the asteroid belt come from an object that was a planetary body and then got ripped apart, likely. That's the thought. Or that it wasn't stable enough because of the gravitational attraction between the moon and Jupiter and the sun, that it just wasn't stable there. And so certainly being able to compare Mercury and the moon to asteroids is really important. And studying asteroids is really important in general because we see a wide range of different types of asteroids. And the thought is that some of those materials came from the outer solar system. So they migrated in and currently reside outside of Mars, but that's not where they always lived. And so looking at the population of asteroids really gives us a better understanding of all of the starting materials of the solar system when our solar system formed and what all the planets originated from. And so doing a comparison between the moon and Mercury against those asteroids certainly gives you an understanding of then what materials were in the outer solar system, what was left behind in the outer solar system to form planetary bodies out there.
Okay. Interesting. So are there any missions that you've proposed that have a chance of being funded? Any rovers to go and drill into Mercury or the moon or et cetera? Or like what is that with your proposal?
Yeah, so I'm actually on several missions right now. So I'm currently on a mission that's orbiting the moon now called the Lunar Reconnaissance Orbiter. And I'm working with an instrument called Diviner, which looks at the heat that is radiating off the surface. And we use that to understand composition and also the rock properties at the surface. So it can tell you where, and it also gives you temperature. So in essence, it helps you pick where might be geologically interesting to go. I'm also have several future missions in the works. So Lunar Trailblazer is a small satellite spacecraft that is going to go to the moon hopefully at the end of this year and is going to look at mapping water and ice at the poles, but also geologically interesting materials around the moon. And then I'm on 3 other projects. 2 of them are thermal cameras that are going to the South Pole of the moon, one is going to be on a lander, one's going to be on a rover. And those are kind of on the timeline of 2026 and 2028. And then myself and Addie Delg, who's also a professor at the University of Central Florida, we are leading a lander and rover mission to this volcanic spot on the moon called the Grooteisen Domes. And so we will land at the surface on top of a volcanic feature and then use the rover to move across the dome and understand the composition of that volcanic feature, and which will allow us to better understand how it formed and has evolved over time.
Okay.
So we're pretty busy. And that last mission that Addie Dove and I are leading through UCF, that mission's called Lunar Vice, and that will launch in 2028.
Oh, and what's its mission again?
It's called Lunar Vice, and that's an acronym for Lunar Vulcan Imaging and Spectroscopy Explorer.
Okay. All right. Any other missions that you're involved in that are, close to getting some interesting data?
So, Lunar Trailblazer is probably the closest. We're really crossing our fingers that it launches with Intuitive Machines 2 in November of this year. And so then it has a short trip to the moon, and that would get us new data in early 2025 that we would start looking at and analyzing.
Okay. All right, well, very good. Kerri, so what's the best way for people to find out more about all the work you're doing? Where can they go? Is there a centralized repository or?
Yeah, so you can Google me. So just Google Kerri Donaldson Hanna at UCF, and you'll find my research page. I'm also on Twitter as well as Instagram, and our Lunar Vice team and mission also has a website that you can Google and find off the UCF's website, and also has a Twitter page.
Okay, well, very good. Well, Kerri, thank you so much for coming on the podcast. I really appreciate it.
Yeah, thanks so much for the invitation. It was a pleasure chatting with you and talking about the planets in the solar system. It's always fun to do that.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.